Okay, hi guys. Today we are going over Punnett Squares. As you can see on the screen here, you got a set of squares. This is called a Punnett square. Um, Up the top, you've got one set of alleles, or the genotype for the alleles here, and then you've got a second parent over here. So we can call this one mom, this one dad, or however. Um, so how we do this, how we fill in the Punnett square, is we are going to take and this allele here for the genotype big A, little a, we're going to drop it down to both of these boxes. So I take if it'll let me. All right, so I'm going to take that big A and I put it in that box. And I take the same big A and put it in this box. Okay, so this one right here drops down into both of the boxes below it. Um, and then the same thing happens with this allele here. So this little a is going to drop down to both of the boxes below it. So we come over here, we grab that one. And we grab that one. Okay, so now this parent has has shared its chromosomes to both, or all four possibilities here. And now this parent is going to do the same. So now this allele right here, the capital A, is going to go over. Same way as the last one went down, this one goes over. Just put it right beside there. Okay, and then it goes over to this one as well. We tend to put the capital letter in front of the little letter, at least I like to, just because the capital letter is the dominant one, and so it's going to hide the recessive, the little one. All right, so now this little recessive one here is going to go all the way across to both of these boxes. Like that. Get them to behave a little bit better. Okay, so now this Punnett square is completed. Each one of these boxes inside of the Punnett square represents a possible offspring. And so we look at this in the form of percentages and possibilities. So the question is that you need to answer is, first off, what percent of the offspring have a dominant allele? So if there's four boxes here and we're looking for the dominant allele only, how many of these four would have that dominant allele? So if it's 1 out of 4, it would be 25%. If it's 2 out of 4, it would be 50%. 3 out of 4 is 75%. 4 out of 4 is 100%. So for this one, for how many would be in the for the dominant allele, you have 1, 2, 3. So you actually have 3 separate dominant alleles. So this one, and this one are all going to be the dominant allele. So that means that 75% are going to be contain the dominant allele. And that means that this one alone does not have a dominant letter. So that means that 1 out of 4, or 25%, is going to be with the recessive. Okay. Now, if we look and we take that a step further, here we've got the same thing, same parents, same offspring. And so now we're going to look and we're going to give those alleles, those letters, meaning. And so if capital A means red fur and little a means brown fur, that means capital A is going to be dominant. So red fur is dominant, little a is recessive, so that's brown fur is recessive. So now we can ask ourselves, what percent of the offspring have red fur? So since for red is the capital A, again, we're looking for a capital A. So this one here has capital A, this one has capital A, this one has capital A. So what percent have red fur? And that would be 75%. And then what percent have brown fur or have that little a? That would be 25%. And then a common mistake that we have on these is some of you have asked me about something called codominance, where it's a mixture, but we're not dealing with any mixtures here. It's either going to be red or brown. So the question is, what percent of the offspring would have reddish brown fur? In other words, would be the middle. And that answer is 0%. You're either going to be red or you're going to be brown. Okay, so hopefully that helps you out with understanding how to complete the Punnett squares, but more importantly, to be able to determine what these letters mean and what percentages of each you get.